right, so let's talk about direct sub and some properties of limits. And we posed a question at the end of yesterday's notes that what is true if the limit equals the function value? And hopefully what you saw from that is that if that's true, then f of x is continuous at x equals c, if the limit equals the function value. So you have those places like this where you don't have a limit, of course, that's not what I'm talking about, but if you have something like this where you have a limit, but the function value is different, then it's not continuous. So in order to be continuous, the limit and the function value have to be the same. And so that doesn't seem like a big deal, but in reality it's a very big deal, because if you're asked to find the limit, then you can just find the function's value. At that point. And that's called direct sub. So I certainly know that if I look at the first example, I know that a quadratic is continuous everywhere. So if I want to find the limit as x equals 2, I'm literally going to direct sub that in, and I know you can probably do that in your head, but just to have it there, and I would get an answer of 17. So my limit is 17. I plug in 1, I get, I probably won't write all these out because I think you can get it. I get the square root of 3. So some of you are probably thinking, well, how do people miss these? You'd be surprised, but it's maybe not because of not knowing the calculus, but maybe it's the pre-cal. So you know, okay, cosine is continuous, so I'm going to find the cosine of 3 pi over 4, but if you don't know the unit circle, well then you're going to miss it because of the unit circle, not necessarily the calculus part. So literally every time I am just direct subbing in that value. What is the sign of 0? The sign of 0 is 0 over 5. Is 0 over 5 okay? Yes, 0 over 5 is in fact 0. And so we're rocking along, and when I plug in 0 here, 0 plus 4, that's square root of 4, which is 2 minus 2 over 0, and I get 0 over 0. Well, that's a problem. Okay, that's called the indeterminate form. Direct sub, indeterminate form. I had to think how to spell that. Hopefully I spelled it right. That's when direct sub doesn't work. When you get 0 over 0, well, it works, but it doesn't give you an answer. It has to lead you somewhere else. So you're always going to do the direct sub. If you get 0 over 0, okay, we're going to have to do more, and we're going to save that for another day. But I just wanted to show you an example of when direct sub would not give you the final answer. Likewise, for the next one, if I plug in -2, I would get -2 over 0. When I have 0 in the bottom, of course, that's undefined. So what do I need to do for that? Again, we'll do that another day. So direct sub works if you get anything but 0 over 0, or I'm going to say non-zero over 0, like -2 over 0, 5 over 0, something like that. Now in the same way, good old piecewise functions. We got to think of piecewise functions. So remember we in the pre-cal review, we kind of graphed these, so you get the idea that the graph, I mean, it's in pieces. And remember what could potentially happen at a break point is that I could come up to that break point, and one's an open circle, and then I jump to a different y value, and then it goes. Well, if you have something like this, you know that the limit as x approaches this particular x value would not exist. But we also had the case when I drew one and you have an open circle, but then the next guy comes and fills that in and then continues on. Well, if I have something like that, then the limit would exist. So what it really comes down to is seeing if the y values, do you get two different y values, or do you get the same y values and one of them has a closed circle? So if this question asks for the limit as x approaches 1, I'm basically going to take the left-hand limit and the right-hand limit. So remember, when a limit exists, you take the left and the right. Well, if I'm coming in from less than 1, that's going to be the left-hand limit. So I'm going to pop in a 1, and I am going to write this one out mathematically. So I know that the left-hand limit, if I plug in 1, I would get 5. Now the right-hand limit would be when I'm plugging in numbers greater than 1. So that would be here. So if I plugged in 1 there, I would get 2. So if the left-hand limit and the right-hand limit don't equal each other, then this limit does not exist. Now, many times these are on multiple choice, so these next couple I'm not going to write out. So formally, I'm just going to show you how quickly you can do them. Well, this one, especially this one says as x goes to -2. That's not even a breakpoint. So you're going to be on one curve or one graph, whether you're coming in the left or the right. So I'm just going to plug in -2 into the correct equation. That gives me -1, and that limit would exist. The next one is a breakpoint. So I'm going to find the left limit. So in my mind, I'm like, okay, the left-hand limit equals 5. The right-hand limit, if I plug that one, 2 squared plus 1, that's 5. And boom shakalaka, I have a limit of 5 because the left and right limits are the same. Now after we've taken some limits, we're going to do some properties. Now I wrote the properties, or I have them down there in that box, but honestly, I just don't look at that box for right now. Because that looks kind of complicated, and I'm going to be quite honest. Limits, properties of limits, if you do what you think is right, you're probably right, with the exception of one. But the addition, subtraction, multiplication, they're all pretty easy. So if I ask you this one, the limit as x goes to 4 of f of x plus g of x, I'm just going to take the individual limits. If the limit of f of x is 6, and the limit as x goes to 4 of g of x is 2, and if I ask you to guess at what you would do for the limit as x goes to 4 of f plus g, you'd say, I guess I would add those two limits together, and you'd be exactly right. If I said take the limit as x goes to 4 of g over f, if you kind of guessed, like, well, I'll take the limit of g over the limit of f and get 1/3. Yes, sir. With this one here, I have a multiple and a subtract, so I don't know, 3 times the limit of f minus the limit of g. Yep. And I threw in this last one. It doesn't seem like it doesn't have anything to do with these, but what's the limit of any constant? Well, think about that. The limit of any constant, if I said graph, now e to the pi, that looks like a weird number, but the point is it's a number, because e is a value, 2.71, blah, 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 blah. Pi is 3.14, blah, 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 blah. So that's the limit of any constant. Well, if you graph a constant, it's going to look like that on your y-axis, or on your axis, not your y-axis. So it doesn't matter what x value I'm going toward. Wouldn't the limit of any constant, in fact, be that constant? And the answer is yes. So This shows you the math kind of formally, but again, don't make that harder than it is, because with the limits properties, you do kind of what seems logical. With one exception, and that's this one, the limit of a composite. So the limit of the composite, it's a little bit tricky, but I want you to look at what it says, and we're going to add something to it. It says if I want to do the limit as x approaches c of a composite function, again, notice the difference between multiplication and a composite f of g of x. I'm going to evaluate f of the limit. I'm going to take the limit as x goes to c of the inner function and then evaluate at the outer. But we need to write, and I didn't want to type it in there. I want you to put a big star right here. And this property is only true if, it's kind of hard to write what I'm trying to say, f is continuous at whatever this number is. If f, or your outside function, if your outside function is not continuous at that value, the limit is not going to exist. But f, if it is continuous at that value, you're just going to read off and see what you get. So let's look at these three. Okay, and I'm going to do this in a very weird order. I'm actually going to start with this one. So I'm going to write that this would be equal to g of the limit as x approaches -2 of h of x. Now make sure you're looking at the right graphs. You'd hate to miss it because you just looked at the wrong graph. So let's do this part first. You know how to do limits graphically. You're going to look at the h function. You're going to take the limit from the left and the limit from the right and see if that limit exists, which you are going to the same thing, and you would get 4. So now I'm going to look and see if g of 4 is continuous. And remember with these graphs, you're assuming that remember we said if they wanted them to stop, they would put distinct dots there, so they go on forever. So is the g graph continuous at 4? If I kept drawing that line, if my graph could go on, yes, it would be continuous. So what is my value? What is g of 4? 1, 2, 3, 4, 5. So my limit would be 5. Let's do this one. I'm going to take the g of the limit as x goes to 0 of h of x. Well, we run into some problems because on the h graph, if x is going to 0, my limit from the left and my limit from the right aren't the same thing. So this limit does not exist. Well, how can I find g of does not exist? So if that limit doesn't exist, this limit doesn't exist. And then we have this last one. I'm going to take h of the limit as x approaches -2 of g of x. Does this limit exist? Yep, because on the g graph, my limit from the left and the right, I'm approaching the same value, and I find h of 0. This is one of the most missed problems because you go, oh, sweet, yeah, if I look at this graph, if I look at h, there's a closed dot at 0. But remember what we starred back in that box. The function, the outer function, has to be continuous at this value in order for that property to hold. And so if it's not, you put does not exist. And that's one that is very easily missed because it looks like the answer should be -1. Or you would just, because you're doing h of 0, so you're just kind of thinking about that. But this property with that composite, the outer function has to be continuous at this value. If it is, then you read off the y value. However, if it's not, then you are going to write does not exist. All right, so work on those properties and see what you think. Peace out.